All right, this is a short lecture on a feature in Java called enumerations, and so it's a quite a handy little feature. So I thought I'd tell you a little bit about it. And the basic story here is what we're trying to do is avoid what I call magic numbers. And magic numbers are just numbers in your code that they serve some function as far as the semantics of the program go. Like maybe 5 means your character is going north and 6 means it's going south or something like that. But the problem with such magic, using such numbers to signify different things in your program is it's just not very descriptive or readable, and you're going to eventually forget what those numbers mean, and certainly other people that aren't you are going to have a real tough time understanding what that code is, and they're just a source of a big source of programming bugs. And so Java enumerations are a good way to try and avoid those sorts of bugs and at the same time make your code really nice and readable. Okay, and I'm going to show you how to use Java enumerations, and then I'm also going to show you how you can use it in the switch conditional statement. And here's just a summary of the various problems with magic numbers. Like where do these numbers come from? What do they mean? What you can accidentally type the wrong number. I meant to type 3, but I typed 4. Finding those kind of mistakes in your program can take a very long time, and you're not really doing yourself any favors. You may think you're saving yourself a little bit of time when you first develop it, but trust me, in the long run it will cost you time. Okay, as soon as you accidentally type 4 instead of 3, okay, your program's not going to work, and it's going to take you 15 minutes or an hour to figure out what's going on. And you realize, oh yeah, I meant to type, I mistyped this or something, or I set this to a value that's not valid. Okay, and while we could use direction, integer, I mean integer can store millions of different possibilities, and maybe most of those aren't valid. Okay, so it's kind of inappropriate to allow our variable to range over a lot of values that don't make sense for the program. One way you can sort of address this is to create final constants, and so we could create friendly names for all these magic values. So this would be kind of your first line of defense, and in I think older versions of Java this is kind of the way you had to roll. And now we have friendly names, and now instead of ever referring to 3 or 4, we refer to southeast or south. Okay, so here's an example. Maybe we're trying to represent the directions on a compass, including northeast, north, southeast, southwest, and northwest. All right. By making it final, nobody can change the value. Okay, and we've got a nice friendly constant, and when we type these things, if we mistype any of these, if I leave out a letter or something, it's just not going to compile, and I'm going to find my mistake in in seconds rather than minutes or hours. This is good, but it still doesn't prevent you from doing naughty things. And here we're doing some here I set direction equal to 0 initially, and which direction is that? Well, it's actually north. It's not preventing me from doing that, or setting it equal to 8, which is out of range, or negative 27, 29. It doesn't prevent that, because really to Java, direction is still just an integer, and it doesn't have to obey these rules. And furthermore, I could have one set of these constants for the cardinal directions and another set for a completely different purpose, and if they're still integers, I could mix and match them and get myself into trouble that way too. Also, somewhat tedious to type all this in, to put all the, it just takes a lot of, I'm not talking about really the labels here so much as I'm talking about you have to do final int and then equals 0. Okay, and in your effort to avoid trouble, you've also opened yourself up to a little bit of trouble. You're typing in 0, 1, 2, 3, 4, 5, 6, 7, and you better make sure you do that right, and you don't repeat any numbers or skip some numbers that you didn't mean to, and so on. Okay. And the problem too, as I said, you're not forced to use it, and you're not forced to keep it, there's no sense of bounds to this scheme. Better solution in modern versions of Java, you can use enumerations. Okay, and the easiest way to do this is just declare it outside of the class, and the format is public enum. Okay, short for enumeration. Then you give it a name, okay, just like you give a normal data type. So we capitalize it, and then we provide a list of the different values it can take in friendly English. All right, so it's a comma separated list, and each of the items in the list is a particular one of the set. Okay, and now what we do is whenever we use this enumerated type, we actually use this data type named compass and declare our variable equal to compass, and then we can set it equal to compass.north or compass.northeast, and we're forced to do this. The compiler knows now compass, or the variable direction, is of type compass, and any kind of shenanigans like shown here, it's going to cause a compile error and prevent us. So we're not going to be able to go out of range. We're forced. We must keep direction within the set of things I've listed in the enumeration. Turns out there's also some handy things you can do with enumerations. It's actually an object with some methods that might come in handy, like toString. Given you have a variable of this compass type, you can call toString or send it to system.out.println and get a nice friendly printout of which of these values it is. Instead of just printing out it's 3, it'll print out it's southeast or whatnot. And there's also a values method, and this lets you range over. And so here's something called an enhanced for loop. Okay, that's what the colon is doing here. We're saying loop over all compass directions D, so D is our local variable, and loop over all the set of values that this data type has. Okay, and so that's a handy way if you need to do something like that. If you don't know, maybe somebody's added something to this. If you do it this way, this loop will work even if somebody goes and adds a few more directions to the compass enumeration. And finally, you can also use them in a switch statement. And here's how you might detect the different directions and move a player, an object representing your hero in various directions. And you can switch on a enumerated type. All right, and once you do that, Java knows you're talking about compass enumeration, and then you can just use the short friendly name, and that creates very nice, very readable code. All right, so just to summarize, you should probably strive to avoid magic numbers in your code. It's bad style, and it does lead to a lot of bugs. So try and where enumerations make sense, you should use enumerations. If you've got some other numbers, say physical constants or whatnot, then maybe you want to use a final variable. But you should avoid interspersing lots of magic numbers in your code, because nobody wants to see that. We don't want to we don't know what it means, and you're going to forget what it means pretty quickly too.